Welcome to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen. It is episode 23 of Brothers of the Serpent podcast. Coming to you live, not live, from the 10 by 10 by 10 Tangent Cube of Science. And we have a new addition to the highly overrated, non-existent previous to this staff. So it's really the first addition to this. Kyle and I are obviously the first staff members, technically. But you know, when you're the guys doing the show, and there's no one else doing anything else around you, you don't have staff. But now we do. Yeah. So we have our friend Brett, and we've been talking about this since we first started the show that we wanted to do this, and we've just now sort of been getting the logistics correct and everything.
Yeah, Brett started out by officially observing every topic of the show and listening to every word and sending us endless amounts of text messages about every topic. So we decided that he was the official show observer.
Right, and that he needed to do it live.
Yeah,
instead of
because he was commenting
and correcting us. Days late, you know.
Then he tried to die at the beginning of May. But
that's
he's
right.
back.
That's right. I forgot about that. He freaking he decided to go die for a little bit. Had something like, was it walking pneumonia or something you had?
Yeah. So anyway, he's on. We can hear him in our headphones.
Yeah.
But you can't hear him. So when we get something wrong, which happens pretty much all the time, he will either chime in with a comment to correct us, and we'll hear him in our headphones. You won't hear him. So if we stop talking for a moment, most likely it's because we're listening to something Brett's saying.
Right.
We're going to try to make that as smooth as possible.
Right. The mission statement for Brett's job is to take the standards of this show from getting everything, almost everything wrong, to getting sort of most everything wrong.
Yeah. But
it's going to be a really hard job.
Yeah. So we're trying this out. We did this last episode, and
it worked.
Already people have noticed that we just would stop and they're checking their, like, wait, did something? Hey,
amateur.
Big mistake. You left your
amateur
ringer on. And your flashlight.
My flashlight's good. It's not making noise.
No, it's making extremely high frequency noise.
Yeah.
But anyway, we're going to try to cut down on the lengthy silences while listening to Brett droll on and on and on, correcting us.
An endless list of corrections. It's like when you type something, you type up a paper, and then you run the spell checker, and it's just like red squiggly lines all over everything. You gotta just rewrite the whole thing.
Yeah. I forgot to start the timer
Oh, great.
Come on, Brett. Why didn't you remind me?
Wait, that means like we're in some kind of weird time warp. 0 seconds.
Yeah.
There it goes.
Okay. Anyway.
So the show just started.
Yeah. Welcome, folks. Brothers of the Serpent podcast. 10 by 10 by 10 by 10 by 10 by 10.
And snakes.
Yeah. So what's the deal, man?
Well, we had the request to talk about, like, just kind of go over the whole thing of lifetimes and life expectancies and.
Oh yeah.
So I think we should do some of that. And I know Brett will be able to chime in on this because he's like almost a doctor. He's one of those guys. He's got like mostly a medical degree, and so he knows about this kind of shit, genetics and how do you say it? Is it eukaryotic cells? How do you say that? Yeah, eukaryotic cells. Yeah. So the request basically was like, you know, what is the deal with how long things live? You know, more specifically towards humans, but just in general, like, why do things age and die? Like, what is the mechanism of that? And you know, and then also, like, is it changing for humans? Is stuff getting different?
Yeah.
So as far as I know, there are, like, when you go all the way down to like single-celled animals or whatever you call them, single-celled life forms. There are ones that don't have a nucleus. They don't have their DNA wrapped up in a nucleus. They just have plasmids that can swap with each other, and they don't have telomeres on the ends of their the DNA chains. So when you reproduce, you gotta duplicate this DNA, right?
Yeah.
So telomeres are pieces of that every time you reproduce, every time they duplicate, you lose a piece of it. It gets shorter, and so basically, like that's what causes the aging process. Is like eventually, when your telomeres run low, the duplication process then has errors in it. Right. So then there's a degradation after that. But like that's eukaryotic cells, okay, which is actually considered to be an advancement over the non-eukaryotic, non-telomere carrying cells that are functionally immortal and can duplicate themselves indefinitely. Which is a strange thing, kind of like it's like, well, how come something that's immortal is less advanced? But if you think about it, something that is something that reproduces like this and then has to reproduce a bunch of times and then it will fail in various ways versus something that can just reproduce endlessly and it doesn't really matter. There's no protections or changes. That thing doesn't change. It doesn't evolve.
Huh.
Okay. So lifespans and the sort of degenerational cycle is a big so if you think of some like the Anunnaki if they're really real and they live for hundreds of thousands of years. Presumably they can have children, but their generations are going to be much longer than humans. Right. So every Anunnaki generation of, let's say it's 100,000 years, there are going to be tens of thousands of human generations inside of that single Anunnaki generation. So if the reproduction cycle, the combining of genes from two different members of that species is what causes new things to take place, new and interesting, arrangements of the DNA and everything, like humans have 10,000 times chances to advance.
Yeah. For
every Anunnaki one.
But okay, well, what's the deal about like the chromosomes? Because I remember learning something about like way back the gene pool or whatever.
Yeah.
Was like each person had way more stuff.
Oh, okay.
And so like the more we reproduce, like it gets thinner and thinner or something.
Oh, okay.
Wouldn't that be going the other direction?
Chromosomes aren't those RNA? I'm not sure. They're like the chromosomes are not necessarily part of the nucleotic DNA.
Okay.
Okay.
I really don't know much about this.
Yeah.
Let's hear it, Brett.
Tell me, Brett. Yeah. That's what I was doing, asking you questions. Yeah. Right.
22 pairs.
Specific to reproduction. Yeah. Splits, forms two half pairs. Right, but okay, but the question is like what is those chromosomes are contained within the full strand of nucleic DNA. Okay, so what is the mitochondrial stuff then? Right, but where is it contained?
It comes from the mother, but
okay, that's right. So it's not in the nucleus. Right. Okay, so and then I basically got the stuff about the telomeres right. Is that correct? It's kind of functionally correct. Right.
Yeah.
Right. Yeah. So, and then the non-eukaryotic cells, they don't have a nucleus, right? And they can reproduce endlessly, and they're functionally immortal, basically. But
prokaryotic cells is what he was saying.
Oh, okay.
They essentially have a single chromosome like DNA.
Oh, yeah. Okay. So they have a single chromosome like DNA, and then so they can just reproduce. It's like doesn't require fertilization. It's just duplication, right? They just split.
Yeah.
Yeah.
So what's like I've heard this thing, on various news stories or whatever about people looking for some type of genetic manipulation that would allow us to be immortal or live forever or whatever, that type of thing. Like how so they're dealing specifically with these telomeres, like trying to figure out how to make them
they're for a while they were really excited that because when you see the telomeres being the limiter in terms of being able to reproduce without mutations, without errors coming up in the code, if you can lengthen the telomeres.
Yeah, if you could do some process that would lengthen them, then you could do it over and over.
Right. If you could continue to add to the telomeres, but I don't know I don't know enough about it to say if that research has gone anywhere. I mean, we could have immortals already living among us.
Yeah, but I've read, and I can't say, how many stories, but multiple different stories over, the past few years where they're like new discoveries, leading to, extending human life or possible.
Right, but they're almost. Whenever I read those, they're never talking about that part. They're talking about other stuff like.
Specifically with DNA, something about DNA. But I,
Yeah.
I'm not really giving you enough information here.
Yeah. Well, that's cool. I mean, we just want to kind of patch over the whole subject. So, like, I just found it interesting that what is considered to be the more primitive life forms, these prokaryotic cells, which are basically like bacteria, they don't have a nucleus with their DNA in there. They're functionally immortal. If they aren't killed by something, like whatever, like fire or.
Right, if they don't die of natural causes.
if they don't die from environmental causes.
Yeah, environmental causes.
Yeah. They can live forever. And that's considered to be less developed than the eukaryotic cells, which are not. They have a lifespan. That's interesting.
Yeah.
It must be structure based. The eukaryotic cells are a lot more complex in their internal structure. Anyway, I always go back to that when I'm thinking about lifespans, because this sort of is the grounding for all of the rest of it.
Yeah.
So all of our bodies, the bodies of every single living thing on this earth that has more than one cell in it is made of eukaryotic cells, as far as I know. So only the single-celled bacteria stuff is prokaryotic, or whatever they call it. So if there's ways to... Sweet. I was just told that I got that 100% correct. So I'm going to have to spend the rest of the show getting everything wrong in order to maintain the standards here. Okay, in terms of the question of, like, in the past as opposed to now, what are the lifespans of humans like? Well, that depends on what your sources are. If you look at the ancient texts, we actually live a lot shorter lives than they did in the ancient past. But nobody, no scientist worth his diploma believes that shit. So they think that we're extending human life, but it's usually not as much as people think, because there's this common conception that, like, the average lifespan of primitive man was 30 years or whatever.
Right.
But that's a true statistic, but in the sense that it's also, like, completely gives you a false picture, because that includes the infant mortality rate, which is horrendously high at every point in human history except for right now. So if you remove the infant mortality rate, then people's average lifespan, in other words, people who survive past infancy, lived an average of 70-something years, even in the ancient past.
Yeah.
So,
but also the problem with that statistic, and this is sort of like the problem with all statistical things.
Is that 99% of them are made up on the spot?
Well, no, it's just that they have to pick a time period and an area to make the statistics from. So if you start with the standard model, which is that there was no advanced civilization prior to ours now, that it's been a linear development.
Yeah.
And so you're studying some, say, tribal group, from, thousands of years ago. There's some, guys running around in butt flaps. Then, and their mortality rate is somewhere in the, or not rate, but the life expectancy is somewhere in the 30s. And then you assume that something, another group of people 3,000 years before that, 6,000 years ago, were roughly the same technological development, blah, blah, blah. You know what I'm saying?
Yeah.
So we're not really looking at, like, a specific culture, say, like the people who built the pyramids, because nobody knows really who did it.
Yeah.
But if you're studying a butt flap culture that was around the pyramids 3,000 years ago,
the goddess is watching.
It may be that they were dying, younger.
Right.
Because they didn't have the modern technology, like the technology that we have.
Right, but the thing is that's interesting about this whole concept, though, is that really where our medical technology is doing the most of its work is at the very beginning and at the very end of life. Right. So we have not completely, but largely eliminated the horrendous infant mortality rate problem, which is just it isn't. I mean, it's horrendous to us because of it's just terrible to think of all that. Like that. It's like, I don't know, something like 7 out of 10 babies died in infancy in one way or another.
They would call him like little visitor.
Right, for the first 2 years. Yeah, just call him the little stranger or the visitor or whatever, because you didn't even want to give him a name and personalize him and fall in love with him because they probably weren't going to survive. So our medical technology has solved that in the modern Western world. It hasn't solved it everywhere. And then at the end of life care, most people, there are large numbers of people in Western civilizations that live 10, maybe 15 years longer than they would have. That entire time they are like under massive medical care because they're basically we're trying to keep them alive through things that would just normally take them out in a couple of weeks or months or whatever, which is great. But that's where all of our technology is focused in terms of medical stuff, in terms of increasing lifespans. So on the infant end, we're not adding lifespan. We're just increasing the number of people who can live.
Right.
So, like I said, because like you correct for the infant mortality rate, all throughout the ancient past, as far as we know, any place where we can get, some kind of enough information to have to do statistics where you've got large numbers of burials or whatever, right?
Right.
So, any place in the ancient past where we've been able to do that, we can see that the average lifespan of an adult, okay, somebody who reaches adulthood, is like 70 years, 72 years.
But still, how are they? What are they basing that on? When they?
You can tell how old the skeleton is, basically. That's what they say. Okay.
Right. That's what I'm asking. Like, what if? So let's say this guy, died in his 60s. Are they basing that on things in the body or in the skeleton that are common with 60-year-olds now? Because what if those people back then
that is a question, yeah,
became physically like they were 60 now when they were freaking 300 years old?
Right. Yeah. So any comparison has to be made with a modern person. So it is a comparison. Like, because I saw people were saying, well, like, isn't there some kind of test that can determine the absolute age of something? So like, because you have people coming and claiming to be an age that they're not. The guy says he's 15, but he's probably 28. Okay. So how do you figure that out? Can you do some kind of comparison? Well, yeah, but only if you're comparing him to like known 15 and 28-year-olds.
Right.
And yeah, so if you do that over large amounts of time, especially if you go back pre-Ice Age, the environment is so drastically different, then it may not work.
Yeah. So in a lot of the ancient texts, like people, like in the biblical texts, like people lived before the flood, hundreds of years.
Yeah.
Right. It was not uncommon for certain noble people, or
Noah was 600 something when he was building the ark.
Yeah, and then what was supposedly like the oldest guy, biblical
Methuselah,
guy,
900 and something years. Methuselah.
I thought it started with an N.
It's an M, I think. Methuselah. It's a weird name. It's like Rumpelstiltskin. It always struck me as a strange name. Methuselah was like this. He was like the grandson of Enoch or something like that.
Yeah. But yeah, he lived like 900 something years. Yeah. Shut up, Brett. Okay, it's Methuselah. Fine. Somebody may have translated it to a different name.
He's definitely called different names in the different texts.
Yeah, but okay, so then you have like the king's lists that are where those people are like, living tens of thousands of years.
Yeah. And but it's also just the king. And when they start talking about bringing kingship down from heaven and stuff, you start wondering, like, maybe just that guy lived that long.
Right.
Like, he's enveloped in this kingship. Whatever.
But that was it's sort of the same deal with Noah, because he was...
Right, he was one of the biblical patriarchs.
He was kind of like one of the shining ones or whatever. He he was born from like his mother, but her husband knew that it wasn't his. Like when he came out, he was like all pissed, and then this
That's right.
alien angel,
This alien.
this angel, comes down and is like, no, man, like,
Yeah.
that's that guy. God gave her that
Right. And
baby.
that's some kind of insemination program, right? It seems to
don't
have
know.
gone. I mean, like that's what it looks like. It seems to have gone on for long. All the virgin births.
That could be another thing, like the giants idea.
Yeah.
Like they gave birth to giants.
Yep.
Maybe they were giants in terms of
Age.
life.
Yeah. Yeah. You would become a giant if you were several thousand years old. You may not be immense, but your
To become a wizard?
your experience would be immense.
Yeah.
Yeah.
I don't know if I want to live for thousands of years, man. I'm like, I kind of want to check out what's on the
I
other
want
side
to
of the veil.
already have lived for thousands of years now. I don't want to have to actually go through it. I just want to like already have done it.
Yeah. Once again, I'm like 35 looking at my past going, oh, geez.
So Brett's telling
I
us.
screwed this up.
Brett's telling us, so things we look at to age a skeleton are the presence and deterioration of growth plates, osteoporosis, and how compressed the spine is. Yeah, so that there's...
Yeah, that, like...
But that's comparison to known cases, modern cases, or whatever.
Right, to modern aging.
Yeah.
So...
Yeah, he says it's right, without a frame of reference, it means nothing. So yeah, there is no test that can, like, give an absolute age for a person. You can't just test them as like, okay, here there are things in their body that tell us this person is 14. You just can't do that.
Right.
I can't do this just yet.
So it's when they look at the past and they're like, well, adults live to 70ish or whatever. They seem to be old. Yeah, you're right. Because like I'm remembering now that all the times when they find the skeleton, right, and they talk about the teeth being worn all the way down to the nub.
Yeah.
Which no modern human
Yeah.
even gets close to, because the enamel on the teeth is the hardest material in the human body. Something living long enough to chew on stuff until they're just worn almost all the way to the jawline is, in other words, they don't have dental problems, they didn't have cavities, they weren't rotting
Yeah.
out. They just wore them out before
Yeah,
dying.
yeah.
That implies...
Because they were chewing boiled leather and leaves.
Yes. Nope. I chew ice every day. I crunch on ice cubes. I should wear my teeth out. Doesn't even make a mark.
So yeah, basically when they're like checking the ages of these ancient peoples, they're more or less giving a percentage of their life, like what they
Okay,
consider
yeah.
their life expectancy. So
Right.
they could say
Whatever
like,
its life expectancy is, it's lived through this much.
right,
of it.
it's about 70% through, like because that comparison is more accurate. Like if they look at like all of the modern aging,
Yeah.
like all of these signs of modern aging, and they say like, well, this person died 70% through
Yeah.
his lifespan, which maybe would have been if he was 50 or
Yeah.
whatever. Then they're basically saying, so it's like when people take like dog years,
Right.
They're like, oh well, this dog is like basically 50 in dog years.
Yeah.
They're doing the same thing.
Right. Yeah. There's human years for sure. I mean, the Anunnaki had their Nibiru year.
So this is cool though, because like what when you talked about carbon dating,
Yeah.
and they're using this decay rate or whatever
Yeah.
that is fairly stable. Like in other words, the rate today is pretty stable,
Right.
But we don't know if the rates had changed over time.
Or the rates of incoming material that
Yeah, exactly.
With carbon dating, it's really about the cosmogenic stuff coming in, not necessarily the decay rate of.
Oh, okay, yeah. That's right.
Yeah.
But that was my point. Is
Right.
that, like,
Yeah. Either one of those things could
the
be.
different environment in
Yeah.
the past may throw our dating off.
Exactly.
So it's based on a comparison with what's going on right now. So that's kind of the same way they're doing it, is like comparing it to the life expectancy without, just take years out of it and just
Yeah.
say like the full life expectancy of the human is 100% of life.
Right.
The length of their life.
And then the other one, I mean, when you're looking at a long head skeleton or even one of the double dentition giant skeletons, like
Yeah.
it's a different it's a hominin or whatever, but it's a different species, so you may not know what the signs of, like what looks like arthritis in the joints to us may be a strengthening an adding of leverage.
So do they know then? Like this makes me ask a question. How do they know, or do they know, or do they think they know the lifespan of various fossil?
No, it's just
like,
guesses.
like dinosaurs.
No, it's just guesses.
Like, oh, the Tyrannosaurus Rex lived 50 years.
No, it's just guessing, and it's again based on. It's because really
based on large animals here today.
Right, based on which are all mammals mostly. I mean, we have a few large reptiles, but those are not. Well, the crocodile and the alligator are basically dinosaurs that have survived until now.
And can't they live without if they aren't killed? Won't they just live extremely long?
Yeah, it's hard to. I mean, people have found enormous ones that are that must be really really old, but you can't really tell. Again, you can't cut them up and be like, well, he's 150. You just say he's huge,
Yes.
There are fish. There are fish in the ocean that are. I can't say functionally immortal in the same way that bacteria are, but they will just continue to grow.
Yeah.
And they just don't. They don't really age. They don't get old and die. But the odds stack up eventually, and something's going to eat them. Right.
And then that thing will die because of the mercury in the bodies.
What are you talking about? Fish eat mercury for breakfast. Wait. But yeah, and then it also greatly depends on your environment. Like I was talking about, so there are some ideas about the not the climate, but the sort of the environment of the surface of the biosurface of the Earth, like the lowest layer of atmosphere right next to the surface, which is basically the biosphere. What that was like. Yeah, it goes all the way around.
It's a dome. It's two domes.